Okay guys, here comes the follow-up from the big identities lesson. So the first big identities lesson we had was this set of problems here. I stopped at 57. I wanted to do these ones here separately. These guys are the follow-up because they all contain that one technique called using the conjugate. That is one of the techniques for figuring out an identity, and that comes from the tan box, the big huge tan box on page 197. And the very last hint is sometimes you want to use the conjugate. So this is a perfect example of that. This is number 63. So I'm going to walk you through problem number 63. And the thing is with this one, this took me 9 steps. I will not give you a problem that takes 9 steps. Let's begin. So what I mean by the conjugate is right here. I'm going to use a red pen so you can see where I've been. And this guy right here, the conjugate would be this. Multiply top and bottom by the conjugate. That is sometimes the way you want to start a problem. Now, right here, I'm going to multiply this one by 1 plus cosine x, because it has a different conjugate. Remember, conjugate is a fancy word that just means leave everything alone but change the sign in the middle. And if you multiply top and bottom by the exact same thing in a fraction, you're not really changing it. So this problem, I am going to tell you right now, I did this left hand only. So it's all going to be on the left-hand side. So the right-hand side, I'm not going to touch it. Eventually, this left-hand side is going to look like that. So here we go. On the top part, in the numerator here, I'm just going to work on the first fraction. Here I'd get tangent x times the cosine, so I got minus tangent x cosine x. What's on the bottom? Well, if I take this and I FOIL this in the bottom, I get 1 minus cosine squared x. Now there's a plus sign, so now I'm going to say plus, and then over here, well, just like I did on the other one, I'd be distributing. Whoops, I forgot to do that. There you go. And then we'd get sine x plus sine x cosine x. The whole thing over. Now look, I'm going to take a little, shortcut here and kind of let you see. If I were to FOIL that, I would once again get the difference of 2 squares. Now remember, I'm not going to touch the other side of this problem. The other side is just going to come down and eventually match up. But what do I really have in the bottom now? I have 2 things. I have this thing and this thing. They match exactly, so I have common denominators. But I also know that 1 minus cosine squared x is the same thing as sine squared x, because I have a Pythagorean identity. So let me take you to the next level here. What I'm going to do is just one little move in here. I am going to say this bottom information, hey, bottom information, you are identical to sine squared x. So bottom information over here, you are identical to sine squared x. Now, here's the thing. Let's just pick on this piece of the puzzle right here. Tangent x times cosine x. See, this piece of the puzzle right here, well, I'm not going to touch this. It's going to stay. But if I write tangent x like this, times cosine x, plus, well, I've got some other stuff, and oops, I just realized my phone is going off. This is just the numerator. That is just the numerator, because I can write it as one thing because both of them have a common denominator now. So this whole part, let me highlight this. This whole part right here is this whole part right here. The bottom is just the common denominator. But here's why I did that. Right here I can cancel those guys. And what happens is, and I'm not going to leave out a step, I'm going to have tangent x minus, now what does this become right here? This becomes just sine x. Then I'm going to keep going down the road here, plus sine x, and see, that's the magic right there. I'm going to go, ooh, I get something to cancel. That's the beauty of this part right here, because that's my numerator now. Here's my denominator, haven't touched it, but these guys can knock each other out now. So what I'm doing is I'm slowly but surely taking little pieces of this puzzle and making it look a little bit prettier. Now, there's different ways to go about every problem. There really is. But that's the way I saw this. And then this next move that I'm about to do, all I'm going to do is I'm going to say, if you are in the top and you are in the top, but you both have the same denominator, I could actually split this guy up if I want. I could look at it like this. Tangent x over sine squared x plus, and then I'm going to say sine x cosine x over sine squared x. Hey, guess what? Just right here, just this piece of the puzzle right here, I can cancel one for one. Just that one piece of the puzzle. And what do I get out of that? Well, I get a cosine left in the top, and I get a sine left in the bottom. That's what I get. And guess what? I'm not going to write it out formally yet. I'm not quite there, but that's cotangent. And let's take a look. What am I actually shooting for? What am I trying to make this side look like? Well, in the book, they have it written down for this one as, on this side, cotangent x plus, and then they have, what is it? Secant x, cosecant x. That's what I'm shooting for. Well, look, I already have this part done then. I already have the cotangent x. I have a plus sign, and then now I got to play with this and see how this could possibly become this part. Now, I'm going to erase that arrow, get it out of my way. But let's just focus right here now. And I would say tangent x, well, guess what tangent x is? It's the same as sine x over cosine x divided by sine squared x. That's what I'm going to do. Divided by sine squared x. So I just did it this way. I said, you know what? I'm going to multiply the top by cosine x and the bottom by cosine x. Because if I do that, I get rid of the double fraction. And what do I get left with? Well, in the top, I just have sine x. In the bottom, I have a sine squared x and a cosine x. Well, hey, I can do one of these, takes out one of those. And then what do I have left? Well, I have 1 over sine x cosine x plus, now let's just call this thing cotangent. And it's supposed to look like this. And guess what? It does. This is my last step. I am going to be done at this point because I know that I could take this little fraction right here and say, you know what, you're the same thing as 1 over sine x, times 1 over cosine x. Well, that's just cosecant times secant. That's just cosecant times secant. So what do I really have? I have a cotangent x, right? I have a cotangent x plus secant times cosecant. Well, heckaroo, that's what I'm supposed to have. Cotangent x plus cosecant x times secant x is what this says right here. And that happens to agree with this part right here. This is how it's written in the book. They wrote this. But I can multiply in any order, so this equals this. This obviously equals this. And I would say, dang, I have shown you that one side is equal to the other side of this problem. Now, here's why I did not assign this one for you guys to try, because it's nasty. Look at how much work I had to do just to get it there. But what I wanted to illustrate is these problems here, 61 to 68, that I've highlighted for you to try, they contain this conjugate trick. This conjugate trick is sometimes the best way out. Then again, sometimes this conjugate trick can be a devil in disguise here. I know that if you want to get through 61, 64, 65, 66, 67, this conjugate trick is going to help you. But on number 68, it's going to work against you. So I wanted to compare and contrast this approach. So let me go down. I'm going to scroll down and give you a little hint to start number 68. So number 68 is just in our book. I got to copy it down. It says this. It says sine theta plus cosine theta equals, and then on the other side of this guy, it says sine theta over 1 minus cosine theta. Cotangent theta. Oh my God, that would have been a big nightmare. Cotangent theta plus cosine theta over 1 minus tangent theta. All right, let me make sure I'm there. Yeah. Now here's the deal with this one. Here's the red flag on this guy. And this is what makes 68 so different from the other ones that you'll see. If I were to take this and start with the conjugate trick, I'm going to lose. If I take this guy right here and I go, oh, I'll just multiply by 1 plus cotangent theta. Well, over here I'd have to multiply by 1 plus tangent theta, right? If you do that, you will not have common denominators. You won't. Also, what you're going to end up with, I'm just going to look at this one. I don't have to look at both of them. I'd end up with 1 minus cotangent squared theta. And that is not a Pythagorean identity. This is not caught one kisk. It's not. This guy right here is something we know. This, right, cotangent squared plus 1 equals cosecant squared. That's something we know. This is not something we know. So that should be an indicator to you that that's maybe a dead end on this one. I just want to have you guys look carefully at these problems. How they start out will sometimes determine how they finish. So I'm going to erase this work because this work would not be helpful. It really wouldn't. Would not be helpful to us. And I'm going to show you a little quick hint, because sometimes the easiest way to get through something is to go double fraction. That is what this fraction would look like if I rewrote it using double fraction technique. This is a complex rational. This is something that we would not want to rewrite as a division. Rather, it would be so much easier to just take the whole top part and the whole bottom part and multiply it by sine theta. If I do that, I'm going to end up with something I can use. The same thing's going to go over here. Here's my hint. Treat it like a double fraction. But I'm going to stop right there, and I'm going to say, if you guys follow my lead there, you should end up with something that is totally workable, and you can get there in about 3 steps. Remember, if you're taking about 7, 8, 9 steps to get something done, it's not one I've assigned you. I have skipped some problems specifically because I know they will have 9, 10 steps in them. Don't get trapped going down the wrong avenue. If something's not feeling right, chances are it's not. But this is my hint for number 68. Okay? And that is the last question we're going to do on that page. We've done quite a few identities. So we're going to take a look next at some computational trig. And doesn't mean we're completely done with identities. They really never go away. But we're gonna pick up the pieces of the puzzle that we have not yet done. And we're going to be doing computational trig till we hit the next unit test, actually. So anyway, guys, there you go. Good luck. If you have questions, Zoom room.